Welcome to lesson 23, lecture 2. Competitive markets produce more than the socially efficient level of output when a transaction creates an external cost. Let's unpack this statement by working through an example. Suppose this graph has the demand and supply for steel. The height of this blue demand curve measures the value of the last ton of steel produced. We measure the value of the last ton by the highest price someone is willing to pay for it. After all, a rational consumer would pay $18 for a ton of steel if the value was greater than 18, but would not pay 18 if the value was less than 18. Since the height of the demand curve is the highest price someone is willing to pay for the last ton, the height also equals the value of the last ton. For example, the demand curve shows that the quantity demanded increases from 3 to 4 when price falls from 20 down to 18. This means that someone is willing to pay $20 for the third ton, but not for the fourth ton, and that someone is willing to pay $18 for the fourth ton, but not for the fifth ton. Since the most someone is willing to pay for the fourth ton is $18, we know that some consumer values the fourth ton at $18. Tied to the supply curve, the red curve, measures the private marginal cost of the last ton. The private marginal cost is the marginal cost paid by the producer, but does not include any external cost borne by the bystanders. Since a competitive firm maximizes profit by producing output only when price is greater than marginal cost, the supply curve is the private marginal cost curve. Since the quantity supplied is 3 when price is 8, the marginal cost is $8 when the quantity is 3 tons. Competition pushes the market to an equilibrium that equates the value of the last unit produced with the marginal cost of the last unit produced. In our example, the equilibrium quantity is 8 tons. When output equals 8 tons, the value of the last ton produced, the height of the demand curve, equals the marginal cost of the last ton, the height of the supply curve. Both of those, the value and the marginal cost, both equal 14 when the quantity is equal to 6. In lesson 19, we showed that equating the value of the last unit with its marginal cost maximizes the standard of living and gave the market a cheer. However, lesson 19 did not consider what happens when the transactions between buyers and sellers impose an external cost on bystanders. Let's look at what would happen if pollution created by the production of steel creates a $12 external cost paid by people living downwind or downstream from the factories. This external cost drives a wedge between the private marginal cost and the social cost. Social cost is the sum of the $12 external cost per ton of steel plus the private marginal cost. For example, when quantity is 3, private marginal cost is 8, and social cost is 8 plus 12, which is equal to 20. We can graph the social cost curve easily by adding the external cost, $12, on top of the private marginal cost to obtain the orange social cost curve. The height to the social cost curve measures the social cost of the last ton. For example, the height to point B, $20, is the social cost of the third ton of steel. The socially efficient quantity equates the value of the last ton and its social cost. The intersection of the social cost curve and the demand curve determines that the socially efficient quantity in our example is equal to 3 tons. When quantity is 3 tons, both the value of the last ton and its social cost equals $20. Increasing quantity from 3 to 6 imposes a deadweight loss on society. the values of the extra tons are worth less than or are less than the marginal cost, or less. I'll start over. The values or prices consumers are willing to pay for the extra tons are less than their social cost. If the quantity can be any number on the number line, then the deadweight loss is the area of the triangle bounded by the social cost curve, the demand curve, the socially efficient quantity, and the um, equilibrium quantity in the market. The notes has an example worked out where we have discrete changes when quantity goes from 3 to 4 to 5 to 6. That concludes lesson 2.